Hey guys, I know you guys are probably getting ready for your AP exam, and I just want to kind of throw some questions out here for you. Um, just want to give you an idea of what you might see. Just a little bit of everything, just a few problems. I'll try to upload as many as I can. In this problem, first they give us a graph. It says the graph of the function f is shown above. Which of the following statements is false? All right, letter A. This is kind of tricky. It says which one is false. The limit as x approaches 2 of f of x exists. Does the limit exist as approaches to does the limit exist? Okay. The limit from the right, from the left, the limit from the right. Does it exist? The answer is yes, it does exist. Okay. Remember, it's not the point because the limit it only approaches, it never gets there. So the limit from the left approaches 2 and the limit from the right approaches also 2 right there. Okay. Or the other way you can think about it is what y value does the limit approach from the left? It approaches the y value of 2. So as x approaches 2 from the left, what's the y value that it's approaching? 2. So it does exist. The limit as x approaches 3 of f of x exist. Here's 3. Does it exist? Yeah, because they're all going to the same y value, right? From the left, from the right, it's approaching 5. So that exists. The limit as x approaches 4 of f of x exists. So from the left, it approaches a y value of 2. From the right, it approaches a y value of 4. So this is the guy, is false, does not exist. What about letter D? Does that exist? Limit as x approaches 5? Yes. Right, they're both from the left and from the right, they're approaching the same. The function f is continuous at x equals 3. Is it continuous? Yes, it's continuous. It's not differentiable, but it is continuous. Okay, so the answer is D. What about the number 2? This is the limit as x approaches pi. Well, when you plug in pi, you end up with 0 over 0. Well, what can you do? Well, you can do L'Hopital's rule. Take the derivative. So the derivative of cosine is negative sine minus, what's the derivative of sine? Cosine 2x times the derivative of the inside, which is times 2. The derivative of 1 is 0. So that's the top. The bottom, the derivative of x squared is 2x. The derivative of pi squared, that would be 0 because that's just a constant. So now we go ahead and plug in, same thing, pi. What's the sign of pi? Remember the unit circle. Okay, pi is over here, so that's negative 1 comma 0. Sign of pi is 0, so that guy's 0. Okay, so this guy becomes 0. All right. And then what about in the bottom? 2 times pi, that becomes 2 pi. All right. And what about this guy? 2 pi. Where's 2 pi? 2 pi is over here. So that becomes 1 comma 0. Okay. What's cosine of 2 pi? Cosine of 2 pi. Cosine of 2 pi is the same thing as 1. So this becomes 1, 0. So 0 minus 2 times 1. 0 minus 2 times 1. Okay. And that would be negative 2 over 2 pi. The answer is negative 1 over pi. And there it is. So remember, when the limit, it becomes 0 over 0. Okay, you can use L'Hopital's rule. What about this one? Limit as x approaches infinity. Okay. Now remember, with infinity, these other values really don't make a difference. What you want to look at is the highest degree. So we're going to just kind of look at this. Let's say we're going to look at square root of 9x to the 4th, and we're going to look at x squared. Now, remember, the square root is the same thing as absolute value. So can we take the square root of 9? Yes, the square root of 9 is 3. Okay, and the square root of x to the 4th would give you x squared. Okay, it would give you x squared. Now, this is all plus or minus over x squared. Now, you have to be careful because absolute value is a piecewise function, remember. So you have to look at this guy here, and hopefully you guys can see it, but it approaches positive infinity, okay? So if it approaches positive infinity, that means we're taking the positive values of this absolute value. So we would use the positive values, which would be 3x squared, and then on the bottom would be x squared. and then the x squared simplify out, your answer is 3. If this was negative infinity, then I would use the negative values, and then this would end up becoming negative 3. Okay, you can plug it into your calculator and take a look at the graph, and you can see what happens as x gets very, very large. All right, guys, number 4. What about this one? This guy is the product rule. Okay, so the first times the derivative of the second, the derivative of sine is cosine, plus the second times the derivative of the first, the derivative of x is 1. So you should get x cosine of x plus sine of x. All right. What about this guy? This is good. Y prime. This guy is, notice that we have an exponent up here. This is the power rule. So you have to do the power rule first. Bring this guy down, becomes 5 times x cubed minus cosine of x to the 4th power, right? You take away 1. But then you got to take the derivative of the inside. What's the derivative of the inside? Well, it would be 3x squared minus the derivative of cosine is negative sine. That makes it positive sine. Okay. And you can probably leave it like that. I think that to be accepted on the exam. All right. Let's do another one here. See if you, hopefully you guys can see this one. It says the temperature of a room in degrees. What does that mean? Remember, the derivative means the rate of change. Think about algebra 1. Rate of change of what? The slope. Well, rate of change of what? Rate of change of y over the rate of change of x. Well, what does x represent? Now that represents time. And the y in this case represents the temperature. Okay. So at, what is it? 5, and we're talking about minutes. At 5 minutes, what's happening? Okay. This guy is changing with respect to time. So at 5 minutes, what's happening? The temperature is what? Changing. How is it changing? Well, it's going up. It's because it's positive. So at 5 minutes, the temperature is going up 2 degrees Fahrenheit. So which one would that one be? Looks like it was a D. The temperature of the room is increasing at a rate of 2 degrees Fahrenheit per minute, 5 minutes after the thermostat is adjusted. So at that specific point, that's how it's changing, okay? Now, at 6 minutes, it could be different. At 5.1 minutes, it could be different. At 4.8 minutes, it's going to be different. Or it could be different, okay? But notice how I did that. H prime represents the slope. What is slope? Rate of change. Rate of change of what? Y over x. X is time. Y is temperature. So at 5 minutes, the temperature, how is the temperature changing? 2 minutes, increasing 2 minutes because it's positive. 2 minutes per, or 2 degrees, 2 degrees Fahrenheit per minute. Okay, so the answer would be BD. But you see how I did that? I just went back to my algebra 1 and I thought slope, y over x. Okay. What about this one? Hopefully you guys can see it, but it says the graph of a piecewise function, okay, that has vertical tangent at x equals -2. Okay, it's a vertical tangent there. Horizontal tangent at -3, vertical tangent there. And at -1, there's a vertical tangent, a horizontal tangent. What are the values of x between the interval which f is continuous but not differentiable? Cool. So where is it continuous? Okay. At x equals 1, is it continuous but not differentiable? Is it continuous? Yes. Is it differentiable? No. Okay. Because remember, differentiable, the definition of differentiable is the rate of change of the limit from the left equals the rate of change of the limit from the right. If you notice, the slope of the left line is not equal to the slope of the right line. Okay, they're different. That's why, for example, absolute value, okay, has the v, right? Why is it not differentiable at 0? Well, because the slope from the left is -1. The slope from the right is +1. Okay, the rate of change is not the same. That's why at cusp, it's not differentiable. What about x equals -2 and 0? Well, -2, that's a vertical tangent. You can't take the derivative. Is it continuous but not differentiable? Correct. What about 0? Is it continuous there? No, it's not. It's continuous and not differentiable, but here it's just not continuous at all. What about -2 and 1? Well, at -2, that's continuous and not differentiable. But what I want, is that continuous and not differentiable? Yup, that's true. Okay. What about 0 and 1? 0, well, that's not continuous at all. So all of a sudden, that's not available. So the best answer would be C, because it says what are all the values? Okay, all the values. So the answer would be C. Number 8. This is a very good question. Always comes up on the AP exam. This is the limit definition of the derivative. So remember, the limit definition of the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. Essentially, and then also the other way they do it is the limit as x approaches a of f of x minus f of a over x minus a. So what happens, guys, is the derivative is taken here. Okay, this is your function. Okay, what's the function? F of x. Okay, what's your function? It's this guy right here. You notice here? So your function is ln of x. That's your function. And what happened? Well, they just plugged in the 4. Okay. And actually, this one might be written wrong, I think. I think in the either that or the bottom, it should be h approaches. Yeah, I think there might be an error in this one, the way it's written. Yeah, because if you notice here, you plug in 0, you would get 0. Oh, no, that's right. I'm thinking about the 4. But take the derivative of this guy. What's the derivative of ln of x? 1 over x. 1 over x. Okay. 1 over x. And then what happens? Okay. You plug in your 4. So the answer is 1 over 4. There it is. Okay. So it's a limit definition of the derivative. Limit definition of the derivative. What about the next one? Which of the following is an equation of the line tangent? Tangent. Okay, that's a key term right there. What does that mean? Boom, derivative. And they give you implicit differentiation at this point here. So what do? When you see write the equation of the line tangent, you start with your point slope form. Okay, write the equation. Write the equation of the line tangent. So this is your x, this is your y. Okay, what is x? That's 1 minus something. Y minus -3. That becomes another -3. So now I got to figure out the slope at that point. So what do I got to do here? I got to take the derivative. Okay, so the derivative of x squared is 2x minus, I'm going to take out the 3, okay, guys? Now, what's the derivative of xy? That's the product rule. So first times the derivative of the second. Okay, the derivative of y is 1, but we're going to do dy dx, plus the second, which is y, times the derivative of the first. The derivative of x is 1. Okay, and that gets left alone, equals 0. All right, the derivative of a constant is 0. Now I got to figure out the slope, dy dx. Well, before I distribute anything, I'm just going to go ahead and plug stuff in. So x is 1, so 2 times 1 is 2, minus 3. X is 1, so that's just going to give me y prime. And then y is -3. Okay, equals 0. So let's see here. Let's go ahead and distribute the 3 now. So 2 minus 3y prime. -3 times -3, that becomes a +9. So now I get 2 plus 9 is 11, so -3y prime, whoops, I'll just do it here, plus 11 equals 0. So y prime is equal to -11 over -3, which is 11/3. That's my slope. That's my slope, okay? So looks like the only one would be this guy, E, okay? So you can notice here, this becomes a positive. My slope is 11/3 and whoops, x minus 1. All right, guys. So very good problems. If you have any other questions, just let me know and I'll just try to do as many problems of these as I can. All right, guys.